Some of you guys asked if this grinder project beat me. Not yet, but it's trying. Welcome to his Quick Workshop. My name is Yuchel. As most of you know, I've been working on this 80-year-old Cincinnati number 2 tool and cutter grinder for the last couple of years. I have posted other restoration videos, so please check them out. The link's up there and in the description. Today we're going to focus on the motor. We'll completely tear it apart and see what we need to do to get it running the way it's supposed to. The motor is pretty dirty, covered in oil and grime and dirt, so I'm just using isopropyl alcohol to clean it up, but I want to make sure that I don't get any inside or the wires in case they get damaged. They're 80 years old. It is 3-phase motor, 3/4 horsepower, and rated at 3,450 RPM at 60 Hertz input power. I'm using an aluminum rod so I don't damage the shaft. There's some grease inside, but I expect it to be way worse than it is. It wasn't coming out, so I took it to my hydraulic press and made a quick work of that. But I'm kind of perplexed because these bearings seem, well, they are shielded. Let me wipe that off real quick. Like I said, these are shielded. This is not part of the bearing. This is a spacer shim. But anyway, and the grease port in this bore comes out right in the middle of the outer race of the bearing. So I don't know how the grease was supposed to get in there. I believe this was replaced at some point with a more modern bearing. And same thing with the other end as well. It is shielded and the grease port comes out right about there. So I don't know what's going on. It's entirely possible that when they replaced the bearing to a modern one, they had to build this spacer, I think. Let me wipe this off and we'll see what brand the bearings are. Actually, all the black color you see on the windings are from the original insulation coating. The grease is just on the bottom of the casing, which is really good. I have the motor disassembled and did rough cleaning, and let's take a look at what we found. First of all, I'm pretty certain this is a genuine original Cincinnati motor. It has the correct plate over here that I have it covered up so I don't damage it, and also it has key features like this right here on the end bell that mounts to the support mounting bracket. Am I 100% sure? I don't know. But anywho, there's some few things that I found interesting. Both end bells had grease zerk fittings, and this is where it gets a little interesting. When I was taking this pulley off, I noticed it was sitting pretty far out on the output shaft, and that was because somebody added a 1/4 inch spacer at the back of it so that it would sit out further. In fact, this nut that tightens it, thread was engaging maybe halfway through, and it was really loose. And things got a lot more interesting as I pulled it apart. Someone replaced the bearings with double sealed bearings, but they did not remove the grease zerk fitting. So subsequent owners didn't know any better. Why would they? They kept pumping grease into them. Well, grease, these bearings don't take grease. So it just got built up between the spacer and the bearing on both sides, and that old bearing just turned into thickened molasses. So there's a lot of resistance when you turn the bearings. Very interesting. And speaking of spacers, these two spacers were added when they replaced the bearings. Hey, it's future me. After filming this section, I was able to take a look at it a little more, and I came to a different conclusion. These are not spacers. Remember, these were facing inward like this, with bearings facing outside? Well, these are to keep the grease out of the rotor and the stator. The inner diameter on these are bigger than the bearings, and we can see that now that I pulled them off. These guards go on there, and actually the thickness of the guards are narrower than what is machined on here. So it was never intended to touch the inner race of the bearings. And the outside diameter is a pretty close fit to what's machined on the end bells. They are maybe 3 thou undersized, so they don't rub, although I see some signs of rubbage. And yeah, so when they replaced the bearings to sealed bearings, there was no need to install these back in because they're not doing anything. The bearing's not resting on it. It's not even touching. So whoever rebuilt this motor at some point, initials LJL, yeah, should have left these out. And it gets even more interesting. At the back end, there's this wire wave washer. It's not a washer, but let's use that term. What it does is provides preload on the bearing outer race. And there was also a shim. So shim would go on there, and the wave washer that gets pressed onto the end of the bell housing. At the front, there was also a shim, but someone tried to make their own wave washer out of a shim, and they clearly did not even bother making it symmetrical. They didn't bend it in the middle. It is pretty shoddy. And there is another wire wave washer. So that went on here and there somehow, and that provided preload on this bearing as well. So what I need to do is start from zero and figure out where this rotor should sit relative to the stator, and figure out what spacers I need. Well, these bearings are going to go. So once I determine where it needs to go, I can either look for correct width bearings or make correct width spacers. That's in a nutshell what I found.
No, this is me in a nutshell. Help! I'm in a nutshell!
I thought it was just going to be a simple clean, clean out the old grease and repack. But no, it just, things never turn out simpler than you think.
My appetite, don't leave me here high and dry. Oh, well, I don't wanna jinx it, baby, and twist myself at the spine. Don't wanna overthink it, baby. It's just
After all the measuring, here are the dimensions I came up with for all of the relevant components of the motor. And the one on the right was measured using the DRO on the lathe, and the difference came out to 8 thousandths, which is pretty close. And based on all this, I need a shim at the back end, thickness of around 90.5 thou. Just received some new bearings. Decided to go with NSK Japanese made 6204DU. Remember, the original one is 204. So 6 in that designation indicates that these are deep groove single roll ball bearings that will really help with the axial load. And it is shielded with rubber polymer on both sides. When we push this on to the shaft, it is a tight fit right before where it seats. So we do need to, I'm going to use hydraulic press, but we do not want to apply the force on the outer race because you could damage the balls. So I'm just going to use these grease shields that came out of here. The inner part is wider, and we're going to flip it this way, and we'll let that part contact the inner race. So it'll go right here, and we'll just press it on, and we won't damage the bearing. And no, I'm not sponsored by Home Depot. But if Home Depot wants to sponsor me, hey, I'll talk. We don't want to push it too hard, too far. Yep, right there. Turn the shaft around and doing the other end. Here's a 90 thou thickness shim I made. I thought I recorded it, but I guess I forgot to hit the record button on the camera. The shim is in its place. I'm heating up the end bell to about 160 degrees Fahrenheit so the bearing can sleep in easily. Ooh yeah. Before I disassemble the motor, I marked exactly where the end bell and the middle section line up. So we're going to put it back exactly how they came off. I wanted to clean some of the oil and grease off the connectors and the wires here, and it's really important to use the cleaners that are rated for electrical motors. The original junction box is kind of small, and given how old and brittle the wires are, I wanted a little more bend radius, so I'm replacing it with a bigger box. This is a cast aluminum box from Butt Industries, available from Amazon. I've used it on other projects and I really like them. This is a little ASMR for you. And what do you do if your daughter texts you and says she wants to play cup pong during her school hours? Well, you play. couple of wires had cracked insulation, so I'm cutting out the connectors and putting 2 layers of heat shrink over them. Making sure I didn't cut any strands. This is 3M friction tape. It helps protect the wires from abrasion and vibration. I didn't put it on all of the wires, just the ones that look kinda stressed. I am grouping the wires into a bundle before I put the new junction box on. I looked at a lot of junction boxes that are available, but they had knockouts or they were too small, and the Spud Industries box just fits the bill perfectly. This is called Glen Nut. It provides strain relief for the wire and also keep the dust and moisture out of the box. And yes, I do have a bigger wrench. I don't have the right tool to remove the cable jacket, but if you're careful, you can use a knife. I'm using the SJO cable, which is rated for 300 volts. If you need to go higher than that, you would have to use SO cable that's rated for 600 volts. I'm wrapping up all the terminations with good 3M electrical tape, and I'll put some friction tape over that to further protect them from vibration and abrasion. I'm not saying this is the best way or how you should do it, but this is how I'm doing it. You'll find out everybody has a pretty strong opinion on how to do this. Look at all that room. And this is where I discover somebody forgot to do their job. Yeah, none of the holes are tapped. Fortunately, I have few taps around, so it was an easy fix. And we do not want any of the shavings going into the windings. And just like that, as if it didn't happen. The motor mount is installed to the column. And the motor is back on. Oh yeah, I replaced those oil lines as well. That is a 15 horsepower rotary phase converter from American Rotary. Certainly is an overkill for this grinder, but I got it for use with another machine. The panel on the right is a dedicated 3-phase breaker panel. From there, I have 4 outlets wired to the machine shop and the main shop area. And to test the motor, I have the motor temporarily wired to a switch I removed from another machine. It's a bit sketchy, but it'll be alright. Just in case, I located the fire extinguisher. Oh boy, we're gonna energize the phase converter. Rotary phase converter, 60 amps. That converter is not happy. Alright, let's see if it turns on. Yay, look at me. That sound you hear? That's my phase converter. Well, my motor is running well, nice and smooth, no noises. Can't ask for anything more than that. The phase converter motor, on the other hand, it's not doing good. See, a couple months after I bought that new, I plugged it in and the motor was making weird sounds. So I contacted American Rotary. They told me to take it to a local motor shop, and I did. I had one of the biggest motor shops in the area go through it and replace the bearings on that. And this grinder right here is literally the very first three-phase motor that I've run off that converter. So no use. That motor probably has less than an hour runtime just from testing and when I wired up the shop. So, well, it can't be the bearing because, well, that's a second set of brand new bearings. So something else is going on. We're going to have to take it apart and figure it out. Maybe it'll make a good video or a bad one, I guess, depending on who you are. I appreciate you sticking around and watching. I'll see you next time.